Here's a comforting thought. Research indicates that approximately 6 out of 10 known infectious human diseases are spread from animals. Not only that, about 75% of new or emerging infectious human diseases are spread from animals. The good news is many diseases are host-specific. Almost all herpes viruses, for example. Chickenpox is the varicella zoster virus, which cannot be transmitted to humans by anything but another human. Not all diseases are infectious, of course. For example, cancer or heart disease. Plus, of the diseases that are infectious, that is, caused by a replicating microorganism, not all are contagious. For example, tetanus. You're probably familiar with at least a few new human diseases caused by microbes that originate in animals. These diseases include human immunodeficiency virus, or HIV/AIDS, severe acute respiratory syndrome, or SARS, influenzas like avian influenza and H1N1, H5N1, and H7N9, Middle East respiratory syndrome coronavirus, or MERS-CoV, Ebola, Marburg, Zika virus. We know from recent history that several of these have spread extensively in human populations to cause a global epidemic, also known as a pandemic. So let's explore the biology of emerging diseases and how we use our understanding of wildlife disease to improve public health and to conserve wildlife for the future of the animal kingdom. I'm sure you're interested in this topic. Pestilence and plague have been topics of concern for humans for a long time, and of course are mentioned in the Talmud, the Bible, and the Quran. First, let's think about the most historically impactful disease ever for our species. The disease I'm talking about is the plague of the mid-14th century, otherwise known as the Black Death. Most cases of Black Death were likely of the bubonic type, or started that way. Bubonic means that large boils appeared on the victim's body from infection of lymph nodes. Some victims likely died of pneumonic plague, a form either transmitted by sputum or progressing from the bubonic form and infecting the lungs. Finally, some victims likely succumbed to septicemic plague, where the blood was directly infected. This could occur either as a progression from bubonic or pneumonic, or as a primary infection. Once the Black Death took hold in a community, it spread rapidly. People of means left the cities for the comparative safety of the countryside. This escape did not exist for those who lived in the slums. In fact, in some countries, militiamen were hired by the government to keep people inside the cities, to let no one out unless they had a certificate to leave from a local leader. And very few of these certificates were issued. This epidemic probably arrived in Europe via the Black Sea in October of 1347, brought by rats on trading ships to the Sicilian port of Messina. Then it crossed to Venice, Italy, and by the winter of 1348, it had reached England. After England, it cut its way east across the continent, moving through Scandinavia and Eastern Europe between 1348 and 1350. And finally reaching the western edges of Russia in 1351. At the same time, other ships brought the disease to Alexandria in Egypt, and from there it spread throughout the Near East, through the areas that are now Lebanon, Syria, Israel, Saudi Arabia, Iraq, and last but not least, Yemen. Along the way, the plague killed somewhere between 75 and 200 million people. This outbreak was not the only time this disease hit Europe, although it was the biggest single outbreak. The disease had a resurgence every decade or two from the 14th through the 19th century. One of the worst of these began in the spring of 1665 in England. The so-called Great Plague hit the entire country, though it was London that suffered the worst of it. The spread of the disease was brought to a halt in September 1666, when the Great Fire of London burned down the areas most affected by the disease, the city slums inhabited by the poor. This outbreak killed an estimated 100,000 people, wiping out a quarter of the population of London. Why was this outbreak so severe, and why was it so much worse in London? First of all, Europe's human population had grown rapidly prior to the 17th century plague, and many lived in poverty. Sanitation had not kept up with the growing population. The only way people had to get rid of household and human waste was to throw it out onto the streets. As a result, cities were filthy, and this was a perfect breeding place for rats. A popular belief during the 17th century was that the disease was caused by dogs and cats. Not so. Bubonic plague was and is caused by the bacteria Yersinia pestis, which is carried by rat fleas. The bubonic plague mostly affects rats, but it can jump to humans, and humans with plague often have many flea bites. A pair of rats in the perfect rubbish-stoked environment could breed and produce many offspring. So the filth found in city streets therefore provided the perfect environment for rats and the fleas upon them. Meanwhile, the people of London during the Great Plague were paid by the city government to kill the dog and cat predators of rats, thus inadvertently making the epidemic worse. In addition, the cramped living conditions these people lived in, and the fact that so many of the physically more vulnerable poor lived in London's rat-infested slums meant that many people could not avoid contact with either the rats or someone who had the disease. That's right, the disease was not only transmitted by rats, but by human-to-human contact. The form of plague known as primary pneumonic plague can be spread by droplet transmission, that is, coughing up transmissible infection from the lungs. Plague did not die out with the sanitation and medical advances of the 19th century. A few cases per year continue to be reported around the world, even though we know that rat and flea control is the answer to limiting spread. Plague is still a big problem in prairie dog populations, which in turn adversely affects nearby endangered species like black-footed ferrets. But on the whole, plague in humans has been overshadowed by other rapidly emerging diseases. You're no doubt very aware of recent outbreaks of diseases like SARS, Ebola, avian influenza, and Zika virus. These diseases remain under study, and this much is clear. When humans intrude in a wild environment, humans are exposed to new and potentially deadly pathogens. That's because these fast-moving diseases originate in wildlife and jump to humans. A zoonotic disease, by definition, is a disease that can be spread between animals and humans. Zoonotic diseases can be caused by viruses, bacteria, parasites, and fungi. These diseases are very common. We know, for instance, that pregnant women should not handle kitty litter because the tiny parasitic toxoplasma organism that can be spread from cats to people may be present there. In non-pregnant adults with healthy immune systems, toxoplasmosis typically causes flu-like symptoms, but pregnant women can transmit the disease to their unborn offspring, a condition we call congenital toxoplasmosis. Congenitally infected children may experience loss of vision, mental retardation, loss of hearing, and in severe cases, death. In areas with endemic toxoplasmosis, the prevalence of the disease is linked to mental health and even has some suspicious correlations with soccer performance. Finally, toxo can cause miscarriage in humans and other animals. Although we should certainly be wary of exposure to animal feces, we also need to note that the most common source of toxoplasmosis in humans is not cat feces. It's poor food safety in handling raw meat and even unwashed vegetables. Even if you've never heard these gory details, I bet you're aware of the diseases that common household pets, livestock, or pest animals can transmit to humans. Diseases like rabies from bats or dogs. Raccoons and skunks are the major source in the US for rabies infections in dogs and cats. While infection from dogs is common worldwide, in the US, dogs are less important in the transmission of disease to humans than are bats. Lyme disease from deer ticks carried by deer and field mice is common. And as we discussed in an earlier lecture, diseases like West Nile, Zika, and malaria are transmitted by mosquitoes. But have you ever thought about how these diseases and others affect the animals themselves? Zoologists have to worry about this because we are concerned with animal disease control in zoos and in nature. My friend, National Zoo elephant manager Marie Galloway, still has a difficult time talking about the moment in 1995 when she observed that an elephant named Kumari was a little off. Kumari was the first Asian elephant born at the National Zoo. One minute, Kumari was acting like the sweet 16-month-old calf keepers and visitors had grown to love. And the next moment, she was acting lethargic and not interested in food. At first, Marie hoped it was just a bout of colic, and maybe Kumari could walk it off by the next day. But when she returned to the zoo the next morning, Marie found that Kumari had gotten worse. Veterinarians took blood from the calf, and keepers kept walking her as they would any colicky elephant while Kumari's mom Shanti followed their efforts. As the veterinary staff monitored Kumari over the next 3 days, her condition worsened. She continued to refuse to nurse. Her trunk and legs swelled, and she was running a fever. When she tried to lie down, her mom Shanti made her stand up and use her elephant massiveness to stabilize the half-ton calf. Kumari worsened and her tongue turned purple. Everyone was baffled by the symptoms. Kumari laid down and Shanti walked away, as if she knew something the human caretakers didn't. Veterinarians rushed in with emergency gear and even tried CPR to save the young elephant. It was only a short time later that Kumari died, shocking everyone. Zoo pathology labs are where some of the detectives of the wildlife profession work, and pathologists at the National Zoo and Smithsonian Conservation Biology Institute are at the leading edge of finding, identifying, and characterizing emerging wildlife diseases. These pathologists, heroes for conservation and endangered animal health, spend hours each day cutting into tissues or peering at fecal samples, blood, or other cells and tissues through the lens of a microscope. Their job is to try to identify what has made animals sick or has killed animals, for the health of other animals and even people. They save tissues for years, decades even, to try to determine what is normal and what is pathological in diverse species that we may know little or nothing about in nature. They are unsung heroes working behind the scenes in cold labs that are the morgues of the zoological world and the front line for understanding diseases. Smithsonian scientists first started working on Kumari's mystery killer over 20 years ago. What they saw shocked them at the time. Thousands of tiny hemorrhages in Kumari's heart, liver, intestines, and tongue. This physical evidence suggested the presence of a viral or bacterial organism, but they couldn't be sure until they got the samples under a microscope. Several days later, when the tissue came back fixed on slides, they saw microscopic evidence of viral infection, inclusion bodies in the cells lining Kumari's blood vessels. Working with the samples under an electron microscope, the researchers working with National Zoo's pathologists found a herpes virus unlike any other herpes virus ever described by scientists. It became known as elephant endotheliotropic herpes virus, or EEHV. Unlike one of our common human herpes viruses, herpes simplex that resides in nerve tissue and may cause blisters but is almost never fatal, here was a unique herpes virus that resides in blood tissue and causes death in elephants. Since then, National Zoo researchers and collaborators at Johns Hopkins University and elsewhere have made significant discoveries regarding the biology of EEHV. Although this disease was first discovered in captive Asian elephants because veterinarians work so closely with captive animals and fresh biological specimens, it has now been identified from Asian elephants in range countries, India and Cambodia. Cooperative, multi-institutional research efforts have been ongoing for over a decade to study EEHV, identify multiple strains of the virus, learn about transmission, develop and improve treatments for young elephants, and to find a vaccine. Using polymerase chain reaction, or PCR, to identify the DNA of these viruses, the researchers first discovered that there are different viruses that attack Asian and African elephants, but so far these viruses only cause mortality in Asian elephants. This virus is suspected of causing the deaths of over half of the young Asian elephants in zoos, and we still do not know how many wild elephant calves may have died historically from this disease. Smithsonian's National Zoo veterinary and genetics teams have helped to set up regional laboratories in range countries and can identify the virus in sick elephants within hours so that famciclovir or other medication can be started to save the elephants' lives. And Smithsonian's EEHV diagnostic team has helped to build capacity of in-country teams, so there is a global effort to prevent future Asian elephant deaths from this devastating disease. In order to save wild animals like elephants, scientists need regular access to them, and captive elephants are key to these studies. There are only about 40,000 Asian elephants remaining in nature, a number equivalent to the number of African elephants that are killed each year for their ivory. National Zoo's elephants and other captive elephants from across North America have contributed regular blood samples and trunk wash samples to Smithsonian's herpes virus research efforts as part of the all-out effort to help save Asian elephants from extinction. Over 12 different kinds of elephant herpes virus have now been identified, and 5 are known to cause hemorrhagic disease. Smithsonian Global Health is working with other zoos and a biotech company to develop a treatment for the critical hemorrhagic phase of the disease. This treatment is aimed at stopping the bleeding so that the elephant can survive the most dangerous effect of the infection. As we discussed in an earlier lecture, the tiger is another species that's in big trouble. The International Union for the Conservation of Nature estimates there are fewer than 2,500 adult tigers left in nature, a decline in range and number of 50% from only 20 years ago, and a decline of over 90% compared to only 100 years ago. The threats they face today include habitat loss because of our rising human population, poaching for traditional Chinese medicine, and retaliatory persecution after the cats take livestock. But now, a new threat to tigers has reared its ugly head: canine distemper virus. Veterinarians and wildlife managers have known for years that canine distemper virus affects domestic dogs and other species, but recently the virus has been spreading to new regions and new species. Even the name canine distemper virus may be a misnomer given the diversity of species we now know it impacts. The virus has been found in many large cats, like lions and tigers, as well as raccoons, skunks, foxes, wolves, coyotes, and even ferrets and seals. Most often, the virus is transmitted to these other species due to dogs coming into contact with wildlife, which itself is an effect of habitat loss because people and their pets are now occupying these traditional wilderness areas. But once it gets into the population, canine distemper virus, CDV, spreads from wild animal to wild animal as well. CDV causes fever, digestive problems, respiratory problems, dehydration, and seizures in Amur tigers. Infected tigers often appear malnourished, are disoriented, and are unable to hunt. In 2015, researchers from Wildlife Conservation Society and Cornell University, with European colleagues, convened a meeting at Bronx Zoo in New York City and concluded that CDV could be the last straw for tigers and could cause their extinction. Key to this is that small isolated populations, like the greatly reduced Russian Amur tiger population, could be especially susceptible to emerging disease threats. Populations of 25 or fewer tigers are almost twice as likely as larger populations to succumb to disease like distemper over a 50-year time span. Critically, in many places where tigers persist today, they have been reduced to fewer than 25 animals in that subpopulation. It would seem that vaccination of big cats, as we do with our dogs, might be an answer, but there are at least two challenges for wildlife managers. Delivery of the vaccine is difficult when it is nearly impossible to find these animals who want to remain hidden from human view. And efficacy of the vaccine outside of those domestic species it is designed for is questionable. It may not work for the wild species. Right now, experts are encouraging people to vaccinate their dogs and other captive carnivores in hopes of reducing the rate at which the disease enters the wild population. Another key to combating canine distemper is to protect as many natural areas as possible. If the animals have larger ranges, they will be less likely to come into contact with infected domestic animals and other infected populations. Persistence of endangered animals is dependent on the persistence of multiple subpopulations. Unless it makes the news, most of us don't hear about these sorts of disease threats sweeping through wild populations. The diseases that do make it onto our radar are the ones that affect us humans, as happened in two infamous cases since 2000, the return of Ebola in West Africa and the emergence of the Zika virus in the Americas. Ebola first came on the human scene in the 1970s. Two outbreaks happened at more or less the same time, one in what is now South Sudan and the other near the Ebola River in the Congo, giving the disease its name. Ebola is actually a genus containing 5 viruses, 4 of which can infect humans, and the 5th of which only infects non-human primates. Luckily for us in the Washington, D.C. area, the one that does not infect humans is Reston Ebola virus, which was first discovered in 1989 in macaques in a research facility in Reston, Virginia, a suburb of Washington, D.C. This was the incident made famous by the sensationalistic nonfiction thriller, The Hot Zone. While the book tends to focus on fear and shock over science, turning Ebola into a terrifying boogeyman, the reality is that Ebola is dangerous but controllable, but only with a lot of effort. You probably followed the news during the 2014 West African outbreak, which was the largest outbreak since 1976. You may have wondered just what it would take to stop the spread of Ebola, or if it could be stopped at all. First, it's important to understand where Ebola comes from. Like the Black Death we discussed earlier, Ebola is a zoonotic disease. Its favorite host is believed to be bats, but it can also be hosted by apes, monkeys, antelope, and porcupines. There are very likely some undiscovered hosts, and one of these may turn out to be the most important one for future human spillover events. Ebola enters a human host when a human comes into contact with infected blood, organs, or bodily fluids of the animal, which can happen through hunting or simply through stumbling across a dead animal in the rainforest. Once a human is infected, Ebola travels through direct contact with blood and secretions of an infected person or by objects that have been contaminated with secretions, like sheets and clothing. Obviously, this means the people who are most likely to catch the disease are people who are caring for the ill, either family members or healthcare workers, as well as those handling deceased patients' remains. The outbreak was eventually contained because of disease management practices that the World Health Organization had been developing since the original outbreak in the 1970s. Reducing human-to-human transmission through the use of protected clothing, through safe handling of the deceased, and through good quarantine of the infected and those who had unprotected contact with the infected. What's really interesting about the 2014 outbreak is the data that came out of it. The Red Cross, which was handling burials, kept such good records of who died and where that a group of scientists from Nuffield College at Oxford was able to figure out who infected whom in the majority of cases. In effect, they were able to create a map of the disease's spread. They discovered that a mere 3% of people were responsible for the majority of the disease's spread, more than 60% of the rest of the cases. So in future outbreaks, if healthcare workers can quickly identify and quarantine these so-called super spreaders, they might be able to keep an outbreak from becoming an epidemic. Another disease that garnered a lot of attention in the 2010s was the outbreak of Zika virus in the Americas. Although Zika was first identified in Uganda in the 1940s, only about 24 human cases were documented before 2007. But in 2015, outbreaks began occurring around the world. They were especially prevalent in Brazil, Central America, the Caribbean, and Florida. The 2015 outbreak coincided with a surge in cases of Guillain-Barré syndrome, which often follows a viral or bacterial infection and is an autoimmune disease that can lead to paralysis, and a surge in reports of severe neonatal microcephaly, a birth defect marked by decreased brain tissue. This was the symptom that brought Zika into the public eye, and it's still what dominates most people's discussion of the disease. So where did this sudden surge in Zika cases come from? Well, first of all, it's possible that the surge wasn't really a surge. Most people who are infected with Zika show no symptoms at all. Many people just have mild flu-like symptoms, such as fever, headache, and joint ache. The symptoms that differentiate Zika from the flu are conjunctivitis and rashes. Until Zika got so much publicity in 2015 and 2016, many people may have had Zika and never realized it. So it's possible Zika has been on the upswing for decades, and we simply failed to notice. Another possible reason for the upswing in Zika cases is a change in the global distribution of the Aedes aegypti mosquito. Unlike canine distemper and Ebola, which involve humans intruding on animal habitats, it seems that more often the mosquitoes are the intruders. And the main driver of this intrusion is environmental change. Aedes mosquitoes like warm, wet environments. So as previously temperate zones, like the continental United States, became warmer, they became more inviting to Aedes mosquitoes, allowing them to come into contact with a larger number of humans. And of course, greater human mobility brings humans to more mosquitoes, and the disease to previously uninfected Aedes populations, speeding the spread of the disease. As with malaria and the Black Death, our best hope for controlling the disease is in controlling the insects that spread it. To minimize the impact of pandemic threats like Ebola and Zika on human health and economic and social stability, the U.S. Agency for International Development has launched an Emerging Pandemic Threats Program. The goals of this program are, first, to prevent the emergence of new zoonotic diseases. Second, to ensure early detection of new threats when they do emerge. And third, to control emerging diseases in a timely and effective way. This program aims to bring heightened focus to places and practices around the world that enable not just spillover of new microbial threats, but that also allow their amplification and spread. The USAID program will also invest in One World, One Health policies that connect public health, domestic animal and plant agriculture, the environment, regional and global economic growth, and public education. An extensive interdisciplinary approach that is now required for the prevention and control of our world's emerging disease threats. Modern zoo and aquarium veterinarians are engaged at the forefront of these biological monitoring programs as they help to strengthen real-time biosurveillance by necropsying, that is autopsying animals, both zoo animals and wild animals that die around zoos. This is how pathologists at New York's Bronx Zoo helped public health authorities identify the emergence of West Nile virus in the United States, another mosquito-borne zoonosis. This critical identification of the virus allowed public health officials to understand this virus and educate people to prevent its spread. As surprising as this may seem, your local zoo veterinarian is often part of a global team of wildlife veterinarians developing a longitudinal data set that will allow us to understand the biological and behavioral drivers of new disease threats emerging from animals in nature. They are also experts in understanding how to reduce risk to wildlife, to our domestic animal populations, and to human life itself. You should not fear zoonotic diseases, but you should certainly respect them. Luckily, the Centers for Disease Control says there are many ways you can protect yourself and your family from zoonotic diseases. You can always wash your hands and follow proper hygiene. Zoo professionals wash hands often while singing happy birthday twice when using the restroom. Handle your food safely. Use multiple cutting boards for meat, veggies, and breads. Be sure that meats are cooked to safe temperatures, and always wash veggies well. Make sure your dairy products are pasteurized. Prevent bites from mosquitoes and ticks. We can live with these creatures, it just might take some extra clothing or chemical repellents. Know the simple things you can do to stay safe around your pets and make sure they are vaccinated. And be aware of zoonotic diseases, both at home and especially when you travel, and how you can prevent infection by those diseases. Now let's think about what you know about zoonotic diseases and how you can reduce your disease risk where you live. Do some research on the 3 top zoonotic diseases where you live. How can you keep them in the wild where they belong? Here's to good health for you, humanity, and our world's animals.